And welcome to Lessons in Logic number 36. And we're finally getting to abbreviated truth tables. Yay! Let's try to keep the review pretty short. Logic is the study of methods, testing whether premises of an argument provide good support for their conclusion. The best way for an argument to provide good support is for it to be valid, meaning its premises guarantee the conclusion. It's not possible for premises to be true and conclusion false at the same time. The truth table method allows us to test any argument using proposition logic for validity if we can put it in standard form and symbolize it using capital letters to represent the atomic statements in the argument, meaning those statements which are not made of any other statements. Did I skip over the definition of deductive logic? It's highlighted here in the review. Deductive logic is the study methods of testing whether an argument is valid. The most powerful of all the methods so far in this series is the truth table method. But there is one weakness of the truth table method. You have to have a lot of rows in your chart. The truth table method will chart all the possibilities open to an argument. And specifically, we mean, since the argument is made of atomic propositions, and an atomic proposition is either true or false, and an argument might have any number of atomic propositions. If it has one atomic proposition, there's only two possibilities. It's either true or false, and those possibilities will determine whether the argument is valid or not, whether the premises can be true and the conclusion false at the same time. Example, I am drinking tea, therefore it's not true that I am not drinking tea. That's a good argument. Premises can't be true and the conclusion false at the same time. But if we have two atomic propositions, then there's four combinations. True, 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 false, false, true, false, false. And if we have three atomic propositions, there's 8 different possible combinations for whether they're for how they're true or false. And that, again, those possibilities again determine whether it's possible for the premises to be true in the argument, for the premises to be true, the conclusion false at the same time, determining whether the argument is valid. And if we have 4 atomic propositions, what, 16 of these rows for the truth table? If we have 5, I'm getting 32. The rule is 2 to the power of x, where x is the number of atomic propositions. So this argument here, A horseshoe B horseshoe C horseshoe E or D, tilde E, therefore D. This argument has 5 atomic propositions, A, B, C, D, and E. And that means 2 to the power of 5 rows for its truth table. It's going to be a very long truth table. And if you added an atomic proposition, making the argument a little more complex, but these arguments do exist. There are arguments with as many atomic propositions as you like, or as you don't like. 10. You could have 10 atomic propositions in an argument, 2 to the power of 10. So that's going to be way higher than 32. I mean, the next one up is 64, and after that, 100, my brain, 128. After that, what, 254? And it goes up fast. It's exponential. So just 6 atomic propositions is an almost impossible truth table. It would take you hours, and it would be strongly recommended that you use an electronic spreadsheet so you don't totally botch it and have to start again just because you put a T in the wrong box or something. So truth tables can be very long, and they can have a horrifying quantity of detail. You don't want to do a truth table on this unless it's an abbreviated one, because I could do a truth table for this argument in 1 row, not 32. Well, 2 rows if you count the guide row. So let's set up the guide row, and I will illustrate how this works. How many columns then will I need? A, B, C, D, E, and then premise 1, 2, 3, 4, 5, and conclusion. I'm already up to 11 columns. And maybe I want an E wedge D column as well, because that premise, second last premise, is a little complex. So I think I might need this many columns. Let's see. I'm going to have my guide columns here, and then 1 column for each premise. And now I find I want a therefore symbol. Which sometimes I find it easier just to copy from the internet than to prepare in any other way. So I want a therefore symbol in my conclusion. Now, I may need one more column. Also, I really would like to reformat some of these columns so everything is, oh, great. Everything's taking up the right sort of quantity of space and it isn't necessarily on two rows. That's better. And that's better. But now let's put C wedge, blah, 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 over here. There we go. C horseshoe, rather. All right. So remember, when you fill in this column right here, we're not going to be filling in C. We're going to just keep in mind what are the possibilities open to C. This box here will be for the horseshoe. All right. So instead of filling in 31 more rows under here, we could do it with just this one row we have. Now, I'm ready to illustrate it, but let's not illustrate it just yet. Let's review some of these background instruction things. With the ordinary truth table method, you lay out all the possible combinations of truth and falsity for the atomic or simple propositions in an argument. Then you see if any of the possibilities allow for true premises and a false conclusion. What the truth table method does is you work backwards. You assume that there is indeed a possibility of true premises and a false conclusion. And then you see what that possibility looks like. In particular, you see if it works. If it does work, the argument's invalid. If it doesn't work, the argument's valid. And then at the end, of course, you have to say so. It's valid because the assumption of invalidity led to disaster. Therefore, the assumption was wrong. Or the assumption of validity did not lead to disaster, therefore the assumption was not wrong, and it is indeed possible to have true premises and a false conclusion. And when I say if it works, I mean, does it lead to disaster? And when I say it leads to disaster, I mean it leads to a contradiction. It leads to a statement being true and false at the same time. If an argument is valid, making this assumption is going to lead to the conclusion that a statement is true and false at the same time, which is impossible. Therefore, that assumption is a mistake. In fact, the whole thing is an implicit modus tollens argument. If the argument is invalid, then we have this contradiction. We can't have a contradiction, therefore the argument's not invalid. When it's valid, that's how the abbreviated truth table method is going to work. So what you do is set up a truth table with some guide columns, one for each atomic statement, a column for each premise, and a conclusion column, like I just typed up. Assign a truth value of true to each premise and false to the conclusion. And then fill in the truth value for every column, including the guide columns. Whenever possible, see what follows from your assumption of invalidity, which is step 2 here. Let me make that a little more clear. Keep glancing at the weather because it's beautiful. I like rain. To assume the argument is invalid is to assign a truth value of true to each premise and false to each conclusion, and then fill in the truth value for everything, including guide columns. And whenever possible, see what is guaranteed by this assumption of invalidity. When there's more than one possibility, you may have to add rows even to your abbreviated truth table, and you may have to just guess until you achieve success. Begin new rows when needed. Do only one row at a time is my advice. Now, if at any point every proposition has one and only one truth value on that row, then the argument is invalid. Say so and stop. Otherwise, go to step 5. If any proposition has been assigned 2 truth values, then there is a contradiction on that row. Circle the contradiction and stop working on that row and go to step 6. If other guesses mentioned in step 3 are possible, then do another row and return to step 4. Otherwise, the argument is valid, say so, then stop. And that reminds me, oh, now the rain is pretty serious. I think I'm going to ruin everything if I try to move the camera. But it's a lovely rain. It's very hard. And I would hate to be, for example, bicycling in this. Let's see. According to my notes, I should do a truth table here. Let's see, where was I? I was reminding myself and about to explain to you that I definitely need more rows here because I'm supposed to assign a truth value to every single proposition in this dang argument. And that includes, maybe I don't need an extra row. That will include E wedge D and tilde E and C horseshoe E wedge D and B horseshoe C and A and B and A horseshoe B. But I've got A and B over here. In fact, I've got A repeated here as one of the premises. I've got C as over here. So I don't think I'm going to have to actually add any rows, any columns to the truth table. All right, so now since most of us understand this sort of thing a whole lot better when we see an example, let's go straight to the example. Now, one wrinkle, one rookie mistake to avoid getting confused by is forgetting that this is one premise. C horseshoe, E wedge D is one premise. We're just giving an extra row here. So I keep thinking maybe I should put this in Microsoft Excel. Let's do it the easy way, and then maybe we'll put it in Microsoft Excel. All right, so step one, assume the argument's invalid, which means the premises are true and the conclusion false. So assign a truth value of true to each premise. Not this box. This is not a premise box. This is a box that helps you keep track of the parts of this premise, the horseshoe statement. And remember, the T here is under the horseshoe, not under the C. Okay, anyway, true and false. All right, this is terrible. We're not doing it this way. We need Microsoft Excel. I just need more rows. I need to be able to fill in every box just right. I'd better pause and straighten out the formatting here. And wow, this is so much better. Okay, now we can work with this thing. All right, so we have the argument. We have the atomic propositions here. We have the premises here. We have the conclusion here. And now we fill in every box except for these parentheses and therefore box. So where were we? We were assuming the argument is invalid, which means we assume it's possible to have true premises and a false conclusion. So D is false, tilde E is true, C wedge, no, C horseshoe, open parenthesis, E wedge, D close parenthesis is true. In other words, if C, then either E or D is true. And again, we're assuming true premises and false conclusion are possible. So if B, then C, and if A, then B would be true, and then A is true. So now, that's your first step. That's the assumption of invalidity. Assume that this is possible. Then, your next move is to fill in the details until you reach a contradiction, and then you say the assumption of invalidity, until you are forced into a contradiction, and then you say the assumption of invalidity leads to a contradiction, inevitably, therefore, this argument is actually valid after all, because contradictions are disaster. A statement can't be true or false at the same time. Or until you get one whole row of the truth table, which is going to be just one of those 32 possible 32 rows we could be filling in here, where there's true premises and a false conclusion. In other words, we're assuming that if we made that huge truth table, 33 rows, 32 rows plus this guide row, that we'd find at least one row with true premises and a false conclusion. We're going to see what that row looks like. But if we find that that assumption leads to disaster, then we stop. We find out, no, there is no such row. So if this premise is true, well, that tells us this is true. Let's do one thing at a time. We've assumed that A is true. My brain keeps telling me, hey, D is false. Fill in D being false over here. But no, let's not. Let's just start. Let's go left to right and see if we can fill in. If this premise is true, it tells us this atomic proposition is true. And that tells us that the antecedent to this if-then statement is true. And since the if-then statement is true and the antecedent is true, we can't have a false consequent, can we? No, the consequent has to be true. So B is true. And that tells us something about C because of this next premise. C also has to be true. Now, if C is true, that's going to tell us something using the next premise about E wedge D. If C is true, then C horseshoe E wedge D has to be true for the parentheses and thus. So that means that either E or D is true. Now, what about E or D? Now we could go right to left, we could go left to right, it doesn't really matter. Let's do something simple. Let's go right to left for a bit. DF, let's see, we're assuming the conclusion can be false while the premises are true at the same time, and that means D is F under our assumption, which means that in order for this statement to be true, it's beautiful rain. In order for this statement to be true, E is going to have to be true. E or D is true, but D is false, so E has to be true. That's, in fact, some disjunctively syllogistic reasoning there. E or D is true, but D isn't true, so E has to be true. So that tells us E is true. But we have to fill in the gaps. And look at that. If E is true, that's going to tell us something about tilde. That's going to tell us tilde is false. But wait, we're assuming it's true, which means, our assumption led to disaster. And that's how you know the argument is valid. We assumed that it was possible to have true premises and a false conclusion. That assumption led to the conclusion that a statement is true and false at the same time, which isn't possible. And that's how you know the argument is valid. So this is an abbreviated truth table that proves that this argument is actually valid. So if you're going to do it right, you need to say that the argument is valid. You need to write something like this. The assumption of true premises and a false conclusion led to a contradiction, so the argument has to be valid. There's no escape. I should probably give you an illustration where we have to work with more rows, and fortunately, I've already prepared some notes. So let's do another one. I think I better just stick with Microsoft Excel. I wonder though if I really need to. I really hate copying these things. It's just terrible. I don't know if I want to practice with all three. What I really need to practice is this one, where you have to examine multiple possibilities. So actually, I think I'm going to skip these for now and just practice with this one. So now I'm going to see if I can do this one in Excel. So that's the argument I want to work with. So I'm going to want guide columns for A, B, C, and D. And then my premises, oh, I can't even read this mess. My premises are going to be A wedge B, A horseshoe C. B horseshoe D, so C wedge D. B horseshoe C, therefore C wedge D. I think that's the argument. All right, so A or B, if A then C. A or B, if A then C. Something's wrong. There we go. All right, once more from the top. A or B, if A then C, if B then D, therefore either C or D. And now I really need to straighten out the formatting because this is just impossible. Okay, so let's first make this one. Let's first give ourselves some lines. And now let's make this premise red. And you don't need me to go through this formatting adjustment. I'll see you in a moment. All right, I think we're in really good shape here. We have 4 atomic propositions. We have one premise, another premise, therefore a conclusion. So again, we're going to assume invalidity is possible. Invalidity, we're going to assume that we're going to assume invalidity, which means assume that it's possible to have true premises and a false conclusion. So we say each premise is true. And then we see what follows. Now here it's a bit different. If we go left to right, we're going to have to try several different possibilities because there's 3 ways either A or B can be true. It could be they're both true, or it could be one's false and the other's true, or the other's false and the one's true. So we want something simpler. Again, there are 3 ways this could be true, 3 ways this could be true, because those are conditional statements. So we want to start with the conclusion because it's a whole lot easier if we start the conclusion. If this conclusion is false, since it's a disjunction, both disjuncts must be false. The only way it's possible for either C or D to be false is if C and D are both false. That's a De Morgan's there, isn't it? So C and D are both false. And now that tells us a lot of stuff we want to know. It tells us C is going to be false here and D is going to be false here. So now, if B horseshoe D is true, but D is false, that tells us B is false. The only way it can be true that if B then D is the only way it can be true that if B then D when D is false is if the B is also false. Again, the only way it can be true that if A then C when C is false is if A is not true either. And that tells us, since B is false and A is false, B and A are false over here too, which tells us, oh, well, what do you know? It tells us disaster. It tells us that A wedge B is both true and false. So again, we get to the same results. Now, I hope I gave you a good example of one that's invalid. Maybe I'll just make one up real quick. Let me do an abbreviated truth table and an invalid argument. Let's do an invalid argument, a simple denying the antecedent, perhaps. Let's try copying and pasting a few things and see what we end up with. I want oh, yes, that'll work nicely. I want if A, then maybe I won't straighten out all the formatting. If A, then C, A, therefore C. There we go. Denying. No, this isn't right. Affirming the consequent is what I wanted. Affirming the consequent. All right, so this is an argument that's invalid. Now let's show that it's invalid. Let's assume it's possible to have true premises and a false conclusion. So that means that if A then C is true, and C is true, and A is false. So A is false. What about B? Oh, goodness, that's supposed to be C. Sorry. Rewind just a bit. This is how I should have set up the argument. Our atomic propositions are A and C. So if A then C, C therefore A is our argument, we're going to assume it's possible to have true premises and a false conclusion, which tells us C is true, A is false, which tells us in turn C is true, A is, oh, hang on, look what I botched. I'm trying to assume true premises and false conclusion to show invalidity here. So I need to put a T right here. I can't neglect that. I forgot to put a T for this premise initially. So now let's go back to filling in the details. A is false, C is true, and filling in all the gaps, always fill in all the gaps where A is false and C is true. A horseshoe C is still true, no problem. So this argument is invalid. We can tell it's invalid because the assumption of true premises and a false conclusion does not lead to a contradiction. So there you go. So that's an abbreviated truth table demonstrating invalidity for this argument. It only works if you filled in all the gaps and haven't missed any contradictions. You don't want to miss that. All right. So now let's do one where we have to examine multiple possibilities. And I want to do P horseshoe Q, Q horseshoe P, so P tribar Q, okay? P horseshoe Q, Q horseshoe P, so P tribar Q. Yes, it's working. Now, the formatting is all disastrous. Let's straighten that up. What luck, I can copy and paste the formatting in this manner. That's a mercy. Except I think I'm going to need extra lines, so maybe I can do that differently. I bet I'm going to need 3 possibilities here. Ah, the formatting's messed up. Okay, close enough. In fact, maybe we'll just keep things partially well formatted. All right. So we want to assume true premises and a false conclusion and see if that leads inevitably to disaster. This is terribly annoying. Look how it's not actually formatting things right. Hang on. There we go. I've beaten the stupid software program into submission. So we're assuming that it's possible to have true premises and a false conclusion. Now, there are 2 ways this conclusion could be false. The conclusion P if and only if Q can be false if P and Q have different truth values. There are 3 ways Q horseshoe P could be true. If Q, then P. It can be true if P is true, no matter what Q is, and it can be true if that's right. It can be true if either P is Q or if P then Q is true, if P is true, or if Q is false, giving us 3 combinations: true, true, false, true, false, false. No, wait. True, true, false, true, false, false. I think I got it that time. And P horseshoe Q, same thing. So if we're going to confirm whether this leads to invalidity, whether the assumption of invalidity leads to disaster, then we might need to try all of those. And fill in all the details painstakingly. And frankly, at this point, abbreviated truth tables are no better than regular truth tables. For a longer argument, it might be, but not with this one. This is a simple 4-row truth table. The abbreviated truth table's not looking so useful here. So here's one thing you can do. Keep it a little simpler. There's only 2 ways this conclusion can be false. When P and Q have opposite truth values, you just do those 2. So now, fill in the gaps for each of these 2 rows. All right, we're assuming the argument's invalid. So we're assuming it's possible to have true premises and a false conclusion, right? And that leads us to those columns right there being true and the premises, and this column in the conclusion being false. And there's two ways that column in the conclusion can be false. So we want to look at both of them to make sure that both of them lead to disaster. If that's the case, then the argument's valid. Otherwise, if we just find one of them that doesn't lead to disaster, then the argument's invalid. Our assumption of invalidity of the possibility of true premises and a false conclusion holds out. So where P trie bar Q is false because P is true and Q is false, what happens? In this row, what happens is, sorry, I shouldn't have had these things. Oh, those boxes filled. Here's where we're at. In this row, where P trie bar Q is false because P is true and Q is false, we have P being true, Q being false. Hey, look at that. We can stop right there. This has already led us to a contradiction. So let's try the other one. In the row where I say always fill in the gaps, you can still fill in the gaps if you want to. In the row where P trie bar Q is false because P is false and Q is true, we are still assuming true premises and false conclusion, remember. So then we have, let's see, P false and Q true, and there's no contradiction there. So is the argument invalid after all? Well, we're about to find out. Where in this row, P trie bar Q is false because P is false and Q is true. This is what our second premise is going to look like. Q horseshoe P, true, where Q is true and P is false. But do you notice what's going on here? Disaster has struck. If the if clause is true and the then clause is false, if P then Q, where P, if Q then P, where Q is true and P is false, clearly if Q then P is false, there's no escaping it. So we're led to disaster either way. Disaster. And so that tells us the argument is actually valid because the assumption of true premises and false conclusion leads inevitably to a contradiction. And if we want to, we can explain this in a little more detail by saying there is more than one way to reason it out, but always still lead to a contradiction. All right, so you don't want to end up doing 3 rows on an abbreviated truth table when you could have done just 2 or something like that. So when you have to look at more than one possibilities, start with a conjunction in the premises because that'll tell you that both conjuncts are true, or a disjunction in the conclusion like we recently did with this one, because that tells you that both of those disjuncts are false, or a conditional proposition in the conclusion because that tells you that the antecedent is true and the consequent false, or a negation or a simple proposition anywhere. In fact, always start with those. That will always help. Now, a few brief remarks on the abbreviated truth table method. A valid argument is one in which it's not possible for the premises to be true and the conclusion false at the same time. An invalid argument is one where this is possible. A truth table lays out all the possibilities. The idea of an abbreviated truth table is to assume that there is one possibility where the premises are true and the conclusion false at the same time, and then see whether that assumption works. To assume the argument is invalid, then see whether there are any conditions that are consistent with that assumption. In other words, to assume that somewhere in all those rows on the truth table, whether it's 4 rows or 32 or 256 or 1024 or whatever comes when 2 gets exponential enough, or millions of rows on a truth table, which could easily happen. To assume that there's at least one of those rows with true premises and a false conclusion and find out what it looks like. That's what the abbreviated truth table method does. Instead of laying out all the possibilities, like a full truth table does, we assume that there is a possibility with true premises and false conclusion, and then we elaborate to see if that possibility works out, see if that assumption can be maintained. So this is pretty much the same thing as the truth table method. In fact, sometimes I'll refer to it as a different version of the same method. It's just much shorter because you don't have to examine every possibility. Usually it's much shorter. With with this one, if we've gotten good at doing full truth tables, this might have been more work. Good practice for learning the abbreviated truth table method. But with something like this one, oh, it is so much easier. Two rows total instead of 33. Now let's talk about the counterexample method. The full truth table method gives us helpful guidelines for constructing a counterexample. Basically, it gives us the outlines of a possible counterexample, or the structure of a possible counterexample. Premises will be true, conclusion false, and a few more details based on what's going on in those premises and conclusions. The abbreviated truth table method is doing the same thing. It's just assuming that there is a possible counterexample and confirming or negating that assumption. There is no counterexample to a valid argument form. We're assuming that there is a counterexample to the form of the argument we're looking at when we do the abbreviated truth table method. But the abbreviated truth table method allows us to confirm whether that assumption works. It allows us to look at possibility as well as actuality. In other words, we're looking at relationships of necessity here among premises and conclusion. We are looking at all possibilities, maybe not in detail like with the full truth table method, but when we do an abbreviated truth table, even then we're still looking at all possibilities. There's nothing left to chance. So this is much better than the counterexample method. It's related to the counterexample method. Every counterexample to an argument form will be one of those rows on a truth table with true premises and a false conclusion. And it's those rows that we are studying when we do the abbreviated truth table method. But if you have difficulty with counterexamples, the abbreviated truth table method will allow you to go further. It will allow you to say for sure that there's no counterexample possible. If that assumption of the possibility of true premises and a false conclusion led to the disaster of a statement being true and false at the same time, a contradiction, then we can know for sure that there is no counterexample. Whereas if all we have was the counterexample method, we might look at an argument, fail to find a counterexample for it, and then wonder if we just weren't smart enough to think of a good counterexample. With the abbreviated truth table method, we can be quite sure. And that's all. See you next time. Thanks for watching.